Hey, 4th and 5th graders, today I'd like to talk to you about electricity. Well, you can charge a battery, and a football player can charge downfield, but how is an electric charge different? So, I want you to think about your desk or a book. What do they have in common? Well, they're all made of atoms. Remember when we talked about atoms before? Atoms are the building blocks of all matter. An atom's made of even tinier particles, and we call those protons, neutrons, and electrons. The main difference between a proton, a neutron, and an electron is their electric charge. Electric charge is a property of a particle that affects how it behaves around other particles. So you can remember that protons have a positive charge. I've colored them here red. Neutrons have no charge, and electrons, I've colored them blue here, have a negative electric charge. So we can consider protons as a +1 for each one. So here we have 1, 2, so it's actually +2. And an electron has a -1. So -1, -1, together -2. Alright, so when an atom has equal numbers of protons and electrons, like here in this atom, we have 2 protons, 2 electrons, then the positive charges and negative charges cancel each other. The atom itself has no charge. Well, sometimes they have the same amount. We call those neutral, but there are moments where an atom and another atom get so close that they move the electrons from one atom, because they can move all around, end up moving over to another. Protons and neutrons, they can't move, but electrons can. So look here, this one electron has moved from this atom over to this atom, and so this one now has a positive charge because there's more protons than neutrons, and this one now has a negative charge. There are more electrons than there are protons. So it's actually, there's more of those negative charged electrons. So we call this one, the one on your left, we call this a positive charge, and we call this one a negative charge. Atoms sometimes gain or lose their electrons. Such a gain or loss causes an atom to have an unequal number of electrons and neutrons. For example, in an atom with 9 protons and 9 electrons, when it gains an electron, the atom will have a charge of -1. If a neutral atom loses an electron, the number of protons will no longer balance the number of electrons. The atom will have a charge of +1. Have you ever had a bad hair day? Your hair sticks out in all directions and it won't lie flat? Have you ever wondered what causes that? I'd like to talk to you about static electricity. We talked when we learned about magnets about how opposites attract. Well, the same goes for charges. Particles with the same charge will repel. So if I have 2 protons, they repel each other. They don't want to get close to each other. If I have 2 electrons, they repel. They don't want to be close to each other. But when I have opposites, they actually attract to each other. So a positive and a negative charge will attract. So if I have a proton and an electron, they actually attract to each other. So particles with the same charge will repel. That means that they push away from one another, and particles with opposite charges attract one another. They end up pulling together. Think about when your clothes are all full of static. What happens? They're opposites. Something that you have has positive charge and something you have has negative charge, and they're clinging together. They're attracting to each other. Electric charges can build up in an object. The buildup of charges, we call that static electricity. Static electricity, get that definition, is the buildup of charges. Objects with opposite electric charges attract each other. Objects with the same charge will repel each other. When you brush your hair, electrons move from one strand of hair to the brush. Soon all the strands end up positively charged. Having the same charge causes those strands to repel one another, and then boom, they've all repelled, they stick out. A charged object can also attract a neutral object. If you rub a balloon on your hair, the balloon picks up extra electrons. They give it a negative charge. When you bring the balloon near a wall, electrons in a small section of the wall are repelled and they move away. This leaves a positive charge at the surface of the wall, so the balloon sticks to the wall. Now I'd like to talk to you about lightning. Why does all of this information matter? Well, static electricity is a buildup of charges on an object. The word static means not moving. Charges stay on an object until it comes close to an object with a different charge. Think about walking across the carpet. So this guy's walking across the carpet, and he's building up charges. The electrons move from the carpet to you. So you can see the little blue electrons moving towards him. Because electrons repel each other, they spread all out. They don't want to be close together. They're spreading all out all over your body. So when you end up finding your friend and touching them or anything else, electrons jump off your finger and jump onto that object. And that's when you feel that shock. We call that electrostatic discharge. That's your fancy science name for when you feel a shock. Electrostatic discharge. You feel it as a tiny shock, but sometimes we end up with even bigger shocks as electrons move, like lightning. Not all electrostatic discharges cause small shocks. Some result in huge shocks, like lightning. During a thunderstorm, tiny raindrops or ice particles are bumping into each other. These collisions cause an electric charge to build in the clouds. Positive charges form at the top of a cloud and on the ground, and negative charges form near the bottom of a cloud. When the difference in charge between a cloud and the ground is great enough, there's a huge electrostatic discharge, and we call that lightning. A lightning spark can jump between two clouds, between a cloud and air, or between a cloud and the ground. The temperature inside a lightning bolt can reach 50,000 degrees Fahrenheit. That's hotter than the surface of the sun. So what are some tips to keep safe in a lightning storm? Stay inside during during thunderstorms. Turn off electrical appliances and stay away from windows so that you don't get caught in the middle of all this electrostatic discharge. If you can't get inside a safe structure, stay in a car with a metal top for the storm to pass. Know the weather forecast. If you'll be outdoors, have a plan in case a thunderstorm develops. Now I'd like to talk to you about currents. You can control electrons. You can make them flow through a wire like the way water flows in a river. So when electric charges have a path to follow, as they do in a wire, here's my diagram of a wire, then they move in a steady flow. This flow of charges, we call this an electric current. So here we have an insulator, and then we have our copper wire, and on that copper wire are electrons, see the blue electrons, and they're all moving down this copper wire. Chemical reactions in a battery provide the energy that causes the electrons to flow. An energy station is another source of electric current. So, electrostatic discharges can be exciting to watch, but flowing charges are more useful. Electrons can be made to move through a wire. They make up an electric current. You can use the electric current to do many kinds of useful work. We use electric currents for cooking food, lighting a room, and producing sound. A battery is one source of electric current. Most of the electricity used in schools, homes, and businesses does not come from batteries. Instead, it is provided by an electricity generating station, or we call those energy stations. There are many types of energy stations. They all turn other forms of energy into electrical energy. Wires carry this energy so that all the electrons flow, and they carry this energy from the station to every outlet in your home. These wires may be on poles above ground, or they may be buried below ground. But remember, safety tip, never climb or play near wires, and never dig in ground where wires are present. Be careful. Alright, boys and girls, that's all. So far in this video, you've learned about atoms, and how we end up with static electricity, electrostatic discharge, and even electric currents. What interesting things we've learned about electricity. Happy learning!